I was saying that today we're talking about visualization tasks, and I'm going to do something I haven't done last year, is that I'm going to try to do examples of these tasks that we were talking about in Vegalite, in Observable, using the data set that you will use for your assignment. So essentially, you'll have a lot of help here. Next week's lecture is important for your assignment as well. So we talked about last week when we were talking about storytelling, we discussed the notion of a designer, the author of the visualization, and the viewer, the audience of the visualization. The designer essentially chooses what the visualization should do. That they have usually communication goals. They want to do something, right? The viewer has their goals, beliefs, attitudes, things that we talked about, and that influences how they read things. But in general, one of the questions that the viewer asks, not like literally asks, but in general, sort of they want to know, what can I do with this visualization? Today, this is what we're learning, what we're puzzling ourselves with, is that how can we think about the different ways, the different things that a user can do with a visualization? That's what we talk called tasks, right? So there's a famous paper about Amar and Stasko that they created a taxonomy of user tasks in visualization environments. So some of these tasks are retrieve value, filtering data, compute a derived value, find extremum, sort the values based on something, determine a range, characterize a distribution, find anomalies, and cluster and correlate. Okay? Obviously, these are just a set of tasks. You should definitely read those chapters from the Munzner book that is in your syllabus, because that explains these much more deeply, and you will use these for your midterm, for your work in general. But these are at least good terms to know, right? These are some of the things that a viewer might want to do. So let's start with the notion of the question of retrieving a value. The idea is that we want to find attributes of a set of specific items in a database, right? We want to find specific things. So essentially, we could ask, what was the global sales of Mario Odyssey? Or what is the Rotten Tomatoes rating of Penguin, the series? These are the types of questions that a user can ask with a visualization. So we might want to create a visualization like this, okay? Where it's a bar chart of different Mario games. It's a bar chart of different Mario games, and it tells us, and then using that, we can retrieve the value of a specific game. For example, Mario Odyssey or other Mario games. This is how the code works, and I'm going to show you how this works, and I'm going to repeat some of this stuff, right? So first of all, I'm going to upload the data set to this observable notebook. I have this data set, and I want to load this data set, right? So how do we load this data set? We will go JavaScript. We can video games file equals file attachment, video games, and then we go shift enter. Now we have loaded the data. Now we create the data set, the value. We say video games data equals video games file, that's CSV, and this is something that we did in the lab. Okay? We can create the table to see what values we have. We have the name of the game. This is a pretty large data set. So it's actually the first time you're dealing with a large data set to create visualization. So you have to get creative a little bit. So we have the year it was published, we have genres, we have publishers, we have North American sales, we have EU sales, we have Japan sales, other sales, and global sales. Okay? So how do you want to ask that question? the Mario question. So one thing that we want to do to retrieve a value in programming is to basically go and maybe filter the data, because we can't visualize. This is 16,000 rows, right? So we're going to learn, do a little bit of JavaScript. So we can filter our data set. I prefer to do it in JavaScript before I pass it to Vegalite. Vegalite has the ability to filter as well. But here's what we can do. We can say Mario games equals video game data dot, did I load it? Yeah, video game data dot filter. This is an array function, and what we're passing here is called an anonymous callback function. Okay, inside of this function, we are telling JavaScript what it should filter this array based on. So what I'm going to do is do two things. I can say return. The return value of this function is a Boolean, is a true or false, and it says which one, the true ones, essentially, the returns that are true will be the ones that are filtered. So I'm going to say, I want the type of the name of this game to be string, and I want the name, I want it to be lowercase, to include the word Mario. Let's see if we have done this correctly. See, we have 113 games. We have a lot of games that are Mario. There's too many Marios. So what else can we do? Maybe we don't want all of this. We want to create that bar chart. So maybe we go and say, and we can do a compound filter. You can also filter by global sales, and we can say that should be more than 20. Okay, now we have only 6 games. So we have filtered our data for the user. Okay, now we can do our normal Vegalite. We can say VL mark bar, then data Mario games, then encode. Okay, so I want to create a bar chart. I'm just going to get the X and Y because it's something that we practice. Here is something that we could do. We can decide on the color as well for these. We're not going to give it a different color for each bar. We're just going to say that this should be dark gray, and we don't want no legend. And then we call it render. Didn't work. Gave me an empty. I just mistyped something. It was global sales that I mistyped. Okay. Now we have it. Type. We have the bar chart, and here with the tooltip, we can actually read the value as well. Okay. So now we know the values of these things. We can derive the actual value. We can know that it's sold 40 million, for example. Okay. That was the first example. What else can we do? So we learned about retrieving values, which is find attributes of a set of specific items in a data set. So we now retrieve the values of Mario games that had global sales of more than 20 million. Okay? And this is how we created it. Now we can also filter. Visualization can help us filter information. Given some concrete conditions on attribute values, find data cases satisfying those conditions. Okay, so what were the sales amount of top 5 games in Japan? What action games in North America had the most sales? So we can potentially create a visualization like this, right? Per year, right? And then we can find 2020, and we can say, we can find some values. So let's do this. So here we're not filtering the data. We want to pass the whole visualization. So we can go VL mark tick. Tick is another type of mark. We can just go data, video games data. We pass the whole thing, and then we go encode, and then we go render. Okay. Now what can we do? We can say the Y position should be a quantitative field of Japanese sales, and the title of that should be Japanese sales. Okay? Then we can say the X position should be an ordinal field of year, and then the title should also be year. Okay, let's see if we see it. Yep. So we see this visualization right here, and now we might be able to, so we filtered on Japanese sales, and we can say, okay, in 2020, this was the amount that it sold. We can also use visualizations to help people filter some information more easily, right? So in Big Light, we can just say, okay, color the ones that have a specific condition. So we can say, write a test for it, and you can say, datum, Japanese sales more than 6. So we can say the ones that have more than 6 Japanese sales, and these guys should be red. So now with a condition, you're helping people find or filter the data to the thing that they might ask. In the future, you might create a slider that allows them to highlight the information they want. Hopefully these examples will help you get a better sense of how you might get people to do some tasks. So a compute derived value is to have a given set of data cases to compute an aggregate numeric representation of those data cases. Okay? What was the total sales of different platforms? What was the average sales of different platforms for different years? So we can create something like this, but I'm going to create something simpler for you. So we can just create another JavaScript file. We can go VL mark bar data is video games data encode. So for the y value, we want to have a field n because we want to create the total sales of the platform. There's a lot of platforms, but it's just fine. So we just copy this and right. And then we can say title is platform, that's fine. And then for the X, we can do field Q, we find total sales or global sales. Actually, I'm gonna just go with publisher instead of platform because there's too many platforms. And then we can aggregate the average global sales across different years. There's already too many. We have a lot of platform publishers. So maybe actually platforms would be easier. Platform. We change it to platform. Okay. So as you can see, I don't know, Game Boy Advance has a higher average than, I don't know, these games, these other ones, the global sales. So what you have done is you have helped them compute. Again, you might not do this. You might give them all of the data and users might be able to compute, or you could compute it for them and they are still doing that task. They're computing a derived value from a data set. And then you can do a crazy visualization like this, where you have the y-axis, the platform, on the x-axis, the year, and then for each year, you have the mean of global sales for that platform. You can characterize distribution. This is something that we're going to learn in the next lecture. So the idea, a lot about it. We can learn, the idea is to, given a set of data cases and a quantitative attribute of interest, characterize the distribution of that attribute values over the set. What is the global sales distribution? How does it look like? Is it around 2 million for all games? What is the count distribution of games? Okay, you can do this. It's so easy. Again, I'm not going to repeat this. It's a bar chart. This is actually a histogram or something, right? You're binning. I'm going to show you how to do this next session, but VL mark bar, you can bin 80 cases, but see, this type of visualization doesn't really show us the distribution. It shows us that everything is between 0 and 2, and then there's probably just these really high anomalies. And this is something that in the next lecture, we're going to learn a lot about how to use means, how to figure out what are the anomalies. But here we're looking at the visual ways of doing things. The next task is actually finding anomalies, right? Identify any anomalies within a given set of data cases with respect to a given relationship or expectation. For example, statistical outliers. What were the games that had so much higher game sales than other games? Other games where Japanese sales were more than North American games by a great deal. So for example, we can create a scatter plot like this, and then we can help people find those anomalies. Most of the data is right here, and then these are the ones that are just, there's so much more. The North American and Japanese sales are just so much more than others, right? And then we can see, oh, what are those games? Or we can find the ones that are, the North American ones are more than everything. So let's try one of these. A lot of these will be essentially very close to how you can answer a lot of your questions in your assignment. The video games data and code. This is pretty simple. We've already done this. So you're just going to say the x-axis is quantitative, and that should be North American sales. Just let them in. Thank you for letting me know. Okay? And then the y attribute is field Q, and it's a Japanese sales. Okay? And then you render it. Then you get a scatter plot like this. Okay? This scatter plot is telling you that most games are within these ranges, but there are these weird outlier games. What are they? Let's find out. I'm actually not going to give you the answer of what those games are because you might ask those questions in your assignment, but I'm going to show you how to visualize it. Okay, so we've done this, right? We have done conditional coloring. So the conditional coloring, you will just add a color condition to your visualization. You go, the color of these circles should be based on the condition, and that condition should be something like this. The sales of Japanese sales more than 5, maybe, because this is, everything is less than 5, so these are probably anomalies, and maybe the sales of North American sales more than 15. And then maybe we want to make the value. Okay, now we have better ways of finding anomalies, but essentially this visualization, even though a scatter plot by definition helps you find some of those anomalies because they're just further apart, but you can also reinforce that by coloring. So another task is cluster. Given a set of data cases, find clusters of similar attribute values. The scatter plot that we just created, right, already helps us find a cluster. This is a visualization, and if we want to say, okay, what are the games like that have similar sales? You know that they're around here. This visualization helps you find that. It doesn't give you the names, but you can figure out something to do like that. And then you know that there are a few Japanese games that are around here. That's a cluster, right? But these are all like one-off anomalies. And then maybe those anomalies can be shown with the clusters together. But you can get creative to show clusters. You can create a visualization that says, okay, what genres have similar sales to each other? Then you can create a visualization. You can get creative with different colors, and you can find that, okay, the adventure games and the puzzle games are probably similar to each other. These have similar values, right? And then the shooter games and the sport games and platform games and action games have similar attributes to each other, right? So it helps you find games or genres that have similar things. So this is a form of finding clusters of values. So let's create this too. So we're gonna do VL mark tick data video games data and code. And remember, you don't have to just do the whole code. You can just slowly, one by one, create your visualization. So we know our y. I always think y first because I like the y-axis more. You can say it's a field nominal, and then it'll what value we're looking at. This is wrong. It's a genre, right? And then we would just go title would be genre, okay? And then let's just say vl.x. This is a quantitative. So we're just gonna go global sales and title global sales. Okay, let's look at it. I forgot to do a render. I probably have mistyped something. Let's see. So genre is correct. Was it? And then global sales is NA sales. Can you identify? This would be, oh, mark tick. Thank you. Thank you. This should be mark tick. I should read chat. Boom. Live coding is a problem. All right, so this is our global sales values. We can also see NA sales. Change this to North American sales. All right. And then you can start making, doing other things. You can change the color if you want. You can change the width. And then tooltips, we have a section for interactions. We're going to get there, but please do explore on your own. You can just create a lot of interactivity. So you can hover over the games and read the values. So VL.tooltip is something that allows you to just, I'm going to show you right now. So what do we want to show? For example, the name and the North American sales, right? So we can just go VL.tooltip. And I believe we pass an array. And inside of the array, we go the names of the fields. So VL.field and name. VL.field Q. And now you can hover over these ticks and see what the values are. So this is Wii Sports. This is Super Mario Bros. This is Duck Hunt. And then you can also just add color to make it easier just to distinguish. And you can just go field N. And I don't want any legend. False. And then there's a comma here. So it just helps you to differentiate between genres. Okay? So yeah, here's how you find clusters or add interactivity. Another thing is the idea of correlation. Given a set of data cases and two attributes, determine useful relationships between the values of those attributes. For example, is there a relationship between average age of players and amount of sales? Is there an association between average age of players and in-game purchases? Okay, these are very important questions that you can ask, right? And again, as we're learning about these questions and these types of tasks that a user can do, you're gonna start thinking about those tasks for your own assignments and your own projects as well. Okay, so we're gonna work on correlations in the next session and to learn about how to do that. But remember that you can do this. And again, general visualization to create correlations is a scatter plot, but you can do all sorts of things. We're going to learn a lot about it. Okay? There's another way to categorize tasks. Essentially, viewers don't usually think in terms of what we just learned about, right? Even though this is a useful way for us to think about what users would want to do, right? But this is not how they might think. Sometimes we need to translate between these more abstract terms to something more concrete, something more useful for the users. Is there a relationship? What variables to relate? Correlate X and Y's. Essentially, a sentence that helps users do something. Use scatterplot, right? So these are called actions. And again, read the Monsner book. but there are all these different actions that are important for users, right? For example, an action is to consume, and then under consume, you can discover something. You can present something to someone else. You can enjoy it, right? These are things that the way that people think about things. So one of the examples is analyze, consume, and discover. So essentially, how might you find new knowledge, get that aha moment about your data set, be surprised, right? Discover something, explore existing questions, generate new questions. And it's hard to know what these are in advance, but your visualization can afford people to get those. So this visualization might let you learn something. I like these map visualizations, and we're going to learn how to create them, right? But it's about atmospheric river in California. Surprises you how like different some rain amounts are from other things. And it's surprising and it's interesting, a warm, rainy winter in the east of the United States, right? To show that there's so many differences between this year and that year. This is something that visualizations can help you do. So going back to this idea of analyze, consume, and discover, it is the other side of that storytelling. It is the other side of that analysis that you can think about. You can also present, right? A lot of times you want to present to someone else something that you understand. You want to communicate, you want to persuade, you want to tell a story. How many times has it happened for you that you wanted to say, oh, this policy is wrong and I want to be able to prove it to you? Maybe a visualization would be the way, right? Immigration is bad, immigration is good. Here's how we can show it to you. Instead of bringing a table, something that you can do. Anything that comes, anyone has tried to persuade someone to believe something or change their, I don't know, over a Thanksgiving dinner or something, and then you wished you had more evidence? I just had one of the biggest fights with one of my friends over some stupid thing because I did not have the data that I wanted to, and he started cursing at me, and I was tilted, and it was bad, right? But so maybe I could make a visualization for him and present my idea to him. So another example of something like this is that, hey, I think high grossing movies in, okay, so what was your debate? Do tell. Okay, so maybe you next time bring your visualizations to us and persuade us that this tool, the dating apps, are not meant to find a life partner. Maybe use Vegalite. There you go. Let's see if you can find the data. That's your project, maybe. Very cool. Okay, does anyone agree that high-grossing film movies have gotten worse over time? This is a belief that I hold. It's just depressing to me that Avengers Endgame is just so high-grossing. It's bad. Avatar. This is old, but it's even worse right now, right? Look, the highest-grossing movies, yeah, no passion, right? Look, these are good films. Return of the Jedi, E.T., even like The Lion King. I can sing you all them Lion King songs. But all of the Disney movies in the past like 10 years have just been repeat of the same idea and so boring. Look, I think this should be accounting for inflation. That's a good question. What is the most successful? Is of course Avatar. Let's see. Oh, this is adjusted for. Actually, that is an interesting. I wanted to surprise you all, but you asked a very good question, right? Yeah, these adjusted for inflation, right? These are the highest grossing movies, and I think this shows that they've gotten worse, in my opinion, right? Because, like, look, they used to even sell more adjusted for inflation. I don't know, Exorcist. But what's happening now? Avatar 2, Avengers, Jurassic 36, Frozen 8, Top Gun 39, Spider-Man Far From Home, and then like, exactly. That is also another good point. Bring those criticism of this analysis in. Exactly. High grossing doesn't mean good movies. And actually, that was the question, right? High grossing movies have gotten worse. That is my claim, right? But maybe you can also show this Rotten Tomatoes ratings. Maybe Rotten Tomatoes ratings are not do not resemble a good movie because maybe all them critics are bought and they might be corrupt. Who knows? Okay, so I love how you all are thinking about these types of questions, these nuances in data analysis. And for your data visualizations and for your data analysis, you want to do a similar thing. Okay? But I think this was an interesting example where you could let people explore and identify whether they think higher grossing movies have gotten worse or not. But in general, we sometimes, in general, we can just think and analyze and consume and enjoy. This is something that's we don't usually think about in visualization, right? Sometimes you just want to enjoy learning about something or just figure out something and be pleased by the aesthetics of what you're seeing. I've shown you examples of things like this before, but like you might find pleasure in just visualizing how relationships within a specific movie, I think this is In the Mood for Love, have occurred over time, and whether they happen during the day or whether they happen during the night. And maybe, oh, it's interesting, the movie starts in the night and then there's day and then it ends in the night. It tells you something really interesting, but it's also beautiful. It's also, very elegant. And you can do this, right? And it's not only about the aesthetics. I think there is a joy in learning. There's a joy in figuring things out, being able to understand something. There's a joy in being able to communicate something simply to others. And that's something that you want to be able to do. Then another action is from analyze to produce new information and then derive. This is fundamental to discovery. Essentially, it's to change the visual encoding to make it easier to visually do something. We want to do operations on the data to make it easier to derive. Similar to what we just did here. Maybe you, instead of showing just a scatter plot, you could create a chart like this where it calculates the differences between these, creates a new field, and then visualizes this, right? And I want to show you how to do that here. So we're going to do another example of calculating derived values, and I want to show you how you do that. Here, let's assume that I just want to create a new data set and call it video games data with different. Use better names, but I can use a function called map. This is another array function that passes each item in the array and then calculates the difference. So you can just say return. You can say you can calculate a new attribute in your data. Difference, NA, and Japan. What's the difference between North America and Japan? You can just say the NA sales minus the JP sales. Then you can return D again. So you're just adding something to that. There's better ways to do this, but bear with me. So let's double check if we have created the field. See, we've calculated now the difference between North American sales and Japanese sales. So using this, we can learn, oh, what are those games that sell more in Japan? Okay, now we can visualize this. We can go BL, mark tick. I'm not going to make the same mistake again. Now we pass difference data to it. Actually, I'm just going to copy the name. You create a variable with a long name. Okay, and then encode, and then render. Okay, and now we've done this before. Field Q, difference, NA, JP, and then title, the difference between Japanese and NA sales. And then there's only one position direction, and then you can also just change the color. and just go dot condition. And inside of that condition, again, we've done this before. You just go and do this. And then you might also just add some interactivity. You can just say vl.tooltip. And then inside of tooltip, you pass an array. Then inside of an array, you go vl.field and name. That's it. I think we only care about the name. So we should be able to Monster Hunter, Dragon Warrior. So you can figure out what games are selling way more. Like Monster Hunter apparently sells way more in Japan than everywhere else in North America. Anyways, we can help people calculate this. And you can also do like similar things by, again, then you can mix and match. You can show differences between North America and Japan by platform, and then learn, oh, Sega and PlayStation and like Nintendo have these weird games that sell more, but Xbox mostly sells more in North America. So you learn something about, you have this aha moment about the state of video games, right? And then you see that, hey, PlayStation sells a lot in North America, and then have some games that sells in other countries. You can look at it by action as well. Like shooter games have way more high grossing films in North America. But maybe there's other genres that are more popular. Like role playing, role playing is way, like has a lot of popularity in Japan. There are a lot of role playing games that sell more in Japan. And there are a lot of shooting games, more shooting games that sell more in North America. Okay, so you can help people read this. You can learn something about your data set visually. And then there's another action is that some people might want to analyze, produce some sort of finding, and then record it. This might be just saving a screenshot, but you can just code and say, okay, export the data or save this image, or you can do something creative with your programming. But this is an action that someone might want to do. People might want to include their own findings and refer to it later. That could be to produce new things and call it annotate. So the idea is that we start with a data set that is raw. By analyzing it, we turn it into information, we present it, and that might be turned into knowledge, something that we learn. And then that knowledge is something that we might share with others. So essentially you're adding new data to this, right? You can record your annotations, you can share with others. So annotation is an interesting and important task in visualizations. So something that I did a while ago. I don't have this live. The code is like from 2015, so it doesn't work. I have to one day figure it out, but I'll share a video for you. Like in this example, what I did is that, hey, I wanted people to find something in Los Angeles and say, okay, this is a party area, might be a nightclub. And I did this using Twitter data, and then people could draw a box and visualize it. But you also do this type of annotation in Google Maps. The ratings are type of annotation, productions of new data. The comments are types of annotations. These are all actions that are within the realm of data visualizations, and it helps others then filter the data, not only, for example, by, I don't know, have you had this experience when you say, oh, I want to find a pizza that's not too popular. Like I don't want a pizza with 10,000 because that's probably bland. I wanted something more interesting. You could. Or when you go buy something, you don't only you look at the ratings, you look at maybe the worst comments as well. Another type of action is searching in general. The idea is to look up, to locate, to browse, to explore. We're going to work on these a bunch in our course as you develop visualizations. This requires a lot of data wrangling. These are some important actions. The way you want to think about it is whether they know what they're looking for and they know where to find it. So that's called a lookup. When they don't know what they're looking for, but they know where to look for it, that's browsing. When they don't know where to look for it, but they know what they want to find it, right? That's called locating. And when they don't know anything, it's just called exploring. right? You want to just explore and learn some of these. These are all search behaviors. Okay? Some examples of lookup is find a specific game that you want, that we just did, or find a specific genre. For locate, I haven't updated this, so let's just move on. Is something we might face, right? Mario games are here somewhere. That's a type of locate. That's how you want to locate this, right? Where are they? You don't know. But then you could just filter for the Mario games and show it to people. These are the Mario games. For browse, the idea is that the target is unknown, location is given, browsing for specific categories or genres. And then for explore, nothing is known by the user. You can click around, find games to play, find games similar to ones you like, etc., etc. Lastly, query is that when you have something of interest, you want to carry out queries about them, defined by a scope. You have a single target, maybe you want to identify some information about a paper you're looking at. Maybe you have multiple targets, you want to compare them. Or when you're looking at query of all targets, maybe you want to analyze them. So, for example, to compare, you want to get a subset of all target data items based on a query, do something with it. It's very similar to filtering, right? So this is some example, like you want to see, okay, what is the sales of these Dota 2 values, right? Or do you all know this game Banana? It's just like this banana that's there and you just have it. I haven't played it, but it's weird. It just sells it just has a lot more concurrent players. And you want to compare these two. You can do that with two visualizations and find something interesting. There's another type of query that you can do is to summarize. To yield all targets, get descriptive statistics, and it's similar to these tasks to compute a derived value, to determine a range, to find extremum, to characterize a distribution. So this summary is essentially to learn something about a query that you have. And the last thing is that it's good to think about actions as verbs and then those targets as nouns in a sentence. And you can form these new sentences. And that's it for these tasks. I think it's really important to think about how tasks are decided on. You really want to think about the tasks that your visualizations want to afford, because some visualizations will be better for some tasks than others. And then for some tasks, you might want to add interactions. You learn how to do that in the future. And yeah, that's it for today. We're going to learn, I think, a bit of D3 next week. I think I'll post this video tomorrow. And then, yeah, Mehdi and here's, the reason I did this coding live is so that you have some coding examples to go by. But we will, if we found time, we will do more short videos with other coding examples as well. Send us your questions. If you don't have any questions now, we can end the session today. Is there any questions? I think the atom means it's one piece of the data. It always messes with my head as well. All right, everyone. Thank you. See you all on Monday. No, I won't share my observable because I want you to code it yourself. You have the videos. I want you to type. Please do that. It is good for you. But you have resources better than mine. There is Jeff Hare's and other courses that have most of the things that we have here. It's just that this dataset is your assignment, and I don't want to give you like all of the examples. Just try to get your assignments done yourself.